Hello, in this video we will see two more derivation rules. In the previous video we already learned the derivative of a constant. We found it to be 0, and we also found the power rule, which is the derivation of x raised to a given exponent. So in this video we will see two more rules that we kind of already mentioned in previous videos. One of them is the constant multiple rule. So what the constant multiple rule says is that if you get the derivative with respect to x of some constant c times some function of x, then that is just equal as multiplying the same constant c times the derivative of that given function f of x. So this is our constant multiple rule. What this means is that if you have, for example, 4x and you want to find its derivative, what you could do is just find the derivative of x. So to find the derivative of this, we just find the derivative of x and we multiply whatever we get times 4. And so we know that the derivative of x based on our power rule, so this is x to the 1. And so remember that the power rule says that when you have x to the n and you want to get the derivative of that, this is just n x to the n minus 1. And so in this case n is just 1. And then x to the 1 minus 1, that's 0 times. And so we get just 1 because x to the 0 is just 1, and so 1 times 1 is 1. And so we know that the derivative of x is 1, and so we have 4 times 1 is equal to 4. So we just found the derivative of 4x to be 4. And so you could try it with using the definition of a derivative, and you can make sure that that's true, and of course it is. One way to look at it is that if you remember, we said that d of dx of f of x, the derivative of f of x, was the limit as delta x approached 0 of f of x plus delta x minus f of x over delta x. And so you can see that if you're multiplying f of x plus delta x times c and f of x times c, well, you could just take the c out, right? And so this is just equal to c times the limit of delta x approaching 0 of f of x plus delta x minus f of x over delta x, which is exactly the rule that we have here. So this is the derivative of c times f of x, and this is the derivative, the second one is c times the derivative of f of x. So we just proved it, and you can try it out with plugging in specific numbers for c and f of x, so you can come up with it, and you will see that it's in fact true. And so our second rule that we will learn here, actually we proved it in one of the previous videos, so I don't think I will have time to prove it here like I did for the constant multiple rule. But what this sum rule does, and of course you can always go back to the previous video and check it out, but if you get the derivative of f of x plus g of x with respect to x, those are x's, then that is just equal as getting the derivative of f of x with respect to x plus the derivative of g of x with respect to x. Very well, so this is our rule. What it means is that I remember that in the video that I mentioned, we were trying to figure out what x cubed plus x squared was, and we actually got the derivative based on the definition that I wrote here. So based on this definition, we got the derivative of this formula, and we found out that it was the same thing as getting the derivative of x cubed and then adding the derivative of x squared. So in this case, if we want to get the derivative of x cubed plus x squared, we can just get the derivative of x cubed, and again remember that based on our power rule, we know that this is 3 times x to 3 minus 1, that's 2 squared, so 3 times x squared, and then the derivative of x squared is just 2 times x, and x is raised to 2 minus 1, which is just 1, so 2x. And this is what the sum rule means.